Hello everyone, I hope you all are doing amazing. Welcome to my channel Best Math. I am Justin, your math teacher. We will start with the EoT written part, that is the part 2 for the term 3 exam questions. This is for the grade 10 advance and we begin with the question 16, that is to divide polynomials by using long division. Now, your EOT questions are from 1 to 10. We will start one by one. Now, first thing is you need to look into the given question. You don't need to apply long division to all the problems. Say, for example, here you have a numerator, denominator. Look at this. This is a monomial. It's a single term. There is nothing plus or minus to it. It's not like plus 2 or minus 3, nothing like that. So whenever we have monomials, the division is very simple. You can divide this by each of the above terms. So this will become 15y cubed divided by 3y plus 6y squared divided by 3y plus 3y divided by 3y. What just happened is we did distributive property. We just divide them throughout and now simplify them. For the numbers, you can use the calculator. That's 3 1 times, 3 5 times, 3 1 times, 3 2 times. And here 3y cancels off, it's just 1. And what about this? The numerator power minus the power whatever is down. If there is nothing, it's 1, isn't it? So 3 minus 1. So we have 5, number 5. Y 3 minus 1 is 2. Plus, we have 2 remaining in the number section and 2 minus 1 is 1, or you can just leave it, plus 1. And that is the answer. Such a simple problem. This is because it was by monomials. You can see the written solution over here. Now, here they have done detailed steps. The question is written everything. In your exam, you can just write the same question, write it how I split it out. This is by distributive property or sum of quotients. And then you solve for the powers, 3 minus 1, 2 minus 1, and so on. And then lastly, you write over here the final answer. Similarly, please do try this by yourselves because these are very simple. We will go to the long division problems, but before that, if you see power minus 1, that is inverse. What is the inverse of x? It's basically 1 by x, or it is x power negative 1. So what happens is this term, since it's having negative power, exponent negative 1, it becomes the divisor. It is basically 4y squared. It goes to the new denominator. From the numerator, it goes to denominator and the power becomes positive. So basically how we write this is, I will show you over here. So this is how we write it. This entire term divided by 4f squared. And then you split it out evenly throughout each terms and then solve for the powers and also the numbers. Numbers can be done in calculator, but they are simple. You can just do it in your mind itself. And be careful with the exponents. Upper exponent minus the lower exponent. Now, if at all you're thinking, what if I have, say over here it is 3 and over here it is 4. Then that is going to be f minus 1 because 3 minus 4 will be minus 1, or you can just write it as 1 by f. This is how we write it. So it will be in the denominator. And then you can simply solve it up. Try this as well. Doesn't matter you have many terms. As long as there is no plus and minus, it's just a single term. It's monomial. And you can solve it over here. All the step-by-step methods is shown. Here as well, it's again a monomial. It's having power 2. Just be careful with the powers and then solve it up. This one will require long division. Why? Because it's not monomial anymore. It's a binomial. Now, how we solve such problems is, this is the divisor, the dividend. So what I do is I just write like this. And whatever is given to be divided, n squared plus 7n plus 10, write it out over here. And what are you dividing it with? The divisor is n plus 5. Now, you need to be very careful. To start, you need to start with this first term and this first term. Now, what do you do with those terms? You need to multiply this outer this term n plus 3, only the n must be multiplied by some number over here, some number or term, so that these both will be equal. So what do you multiply this with? If I multiply with 1, I'll get n. No, I need n power 2. So if I multiply it with n times n would be n square. That's the thing. And then it's not over. The next term is phi n, right? Plus phi. Multiply it with n, it will be plus phi n. This is how you get these terms. If you're thinking, okay, what if you have complicated terms over here? How will I get it if you have, say, 2 and stuff over here? It's fine. The another way to remember this is whatever is there inside this, what you're dividing, write it over here, n squared, and what is outside, divide by that. And what is the answer over here? It'll be 2 minus 1, so it's n. So this is this term. When we see a complicated problem, you will understand this method is much easier. Now then, once we have done so much, we need to solve them up. How do we solve this? We change the signs of this in the sense, if this is positive, over here it's no sign, that means it's positive. We change it to negative, and this is already positive, becomes minus. Or some just erase these signs and make them minus minus, it's up to you. Just remember these two terms change their sign. Now n squared minus n squared, add them up, plus and plus, add them up, n squared plus minus n squared is 0, that's gone. Now plus 7n minus 5n, 7n plus minus 5n will be plus 2n. And now this is done, but you have to bring whatever is next down, and that will be plus 10. Now what do? We repeat it. Look over here, this is 2n, isn't it? So I need to multiply a number to n so that I get 2n. So what I can do is this term divided by n is equal to what? 2. So if I multiply this with 2, what sort of 2? Plus or minus 2? This is plus 2n. So I have to multiply with plus 2. N times plus 2 is 2n. 5 times 2 is plus 10. And now change the signs over here. It becomes plus 2 minus 2n. 2n minus 2n, 0. Plus 10 minus 10 is 0. So this is done. You took the last term, you're done with it. This is the remainder. So remainder is 0. So if you divide n squared plus 7n plus 10 by n plus 5, you're going to get n plus 2. And this is a factor. These both are factors of this particular term. So this is how you do long division. Now we will do one more problem where there is a remainder in a while. But there are some things you must remember. See, you always start dividing with a degree 1 term. So whatever is the degree of your given question, this one is n squared, right? So remember your answer will be 1 less than this degree. So if it's n squared, this will be n. If imagine this was n to the power 4 plus n cubed, just an example, okay? And you're dividing this with n plus 5. Then whatever your answer over here will be having n power 3 and then so on. It might have n power 2, it may not have also, but no matter what, it must have n cube as the degree. 1 less than the dividend. So this is one thing, this is important to know whether your answer is true. And once you reach a constant term, right, it's done. When you reach a number, it's done. So now if you're solving this, you'll come like this, say n plus 3. This is a constant. There's no variable. That means that's the end. You will reach the remainder at that time. So these are the things to remember. But most important is practice. Okay. The more you practice, the more easy it becomes. You can see that the detailed method is over here. And that is what we also got. N plus 2 is the correct answer. So that is the quotient. Quotient means after dividing, the answer you get. Now here, this also doesn't have remainder. It's just that this is the divisor. So you're dividing by d plus 1. And you can see that's how we do it. And this is also pretty straightforward. Let me do this one. I think so this has a remainder. But anyways, if it doesn't have, we will do one more. So let me first write 2t to the power 2 plus 13t plus 15 divided by t plus 6. Now, what do I need to multiply? So I know this is a number over here, 2, right? So I have to multiply 2 no matter what. But 2 times t is just 2t. I need squared, so I have to multiply it with 2t. So t times 2t is 2t squared, or you just do 2t squared divided by t, you get this. And what about the next term? 6 times 2 is plus 12t. And change the signs here. This is going to cancel off. It's 0, so I'll just ignore that part. Over here, it'll be 13 minus 12, that is 1t only, t to the power 1. So that is it. Bring the next term down, it's plus 15. Now what next? We have t here, we have t here. So what are you going to multiply it with? There must be a number. It's 1, because t times 1 is t itself. And 6 times 1 is 6. Now we change the signs, this cancels off. But what happens here is 15 minus 6 is 9. So the remainder is 9. So your quotient is 2t plus 1, yes. But there is a remainder. So plus 9. But you just can't write plus 9. That doesn't make sense. Is it the quotient itself? No. This divided by the divisor, t plus 6. This is how we write it. Now, if you know the number division, long division, this is how we write the fractions the same way. Let me just give you an example. 6 divided by 4. So what is the answer? It's 1 times 4. Over here you get 2. So it is, the remainder is 2. You can't continue it further, right? What is the answer? The answer, the quotient is 1. But is it just 1? No. 6 divided by 4 is how much? 1.5. So how do you write this? So whatever is the remainder, so plus, the remainder is there, right? Divided by the divisor. So this is 1 plus half. Or 1 and a half, or you can write it as 1.5. This is how we do it. If you put in the calculator, you directly get 1.5, but this is the method. Same way we follow here. This is the remainder. 2 is the remainder here, divided by 4. Here we have 9, the remainder, divided by t plus 6. I hope this is clear. So this is how we write the quotient with the remainder. And you can see the remainder is 9, and this is how we finally write it out. So please do try the other problems by yourselves. They are worked out over here. Some do not have remainder. Some do have remainder. Let me just check this one, because here it seems to... So you have, let me just solve it up over here. 6y squared plus y minus 2. And over here it's 2y minus 1. So what I would suggest is, don't blindly trust the solution sets. Just think for a while, solve it by yourselves, and then check the answers, because I'm not sure about these signs, you know. So let me just check it. Over here you need to multiply it with 2 times 3 will be 6, and y over here it will be 6y squared minus 3y. Now we change the signs, this cancels off, and this becomes from minus to plus. We have to change to the opposite sign. If it's minus, it becomes plus. So y plus 3 will be 4y, and bring this down over here, it becomes negative 2. So 2y, you have to multiply with 2. So 2y times plus 2 will give you 4y, and minus over here it will be minus 2. So the mistake over here was, this is plus y. Now we change the signs over here. So this 4y minus 4y is 0, and minus 2 plus 2 is 0. So the remainder is 0. The answer is correct here, but it's just that this sign over here had to be plus. Say over here, this one, it's a plus sign. And then we change the signs. Okay, the signs will be changed. This will be minus, and this will be plus. And that's the answers here also. Please do try it by yourself. Okay, now this is an important thing which we must remember here. So you can see there is 4g squared minus 9, and if we divide it by 2g plus 3, we get an error. Let us try this. 2 times over here 2g, so it becomes 4g squared. And what happens over here? 3 times 6g, so it's plus. Now how do we solve? We change the signs. And what do we do now? Is it minus 9 minus 6g? This is having a variable, this is a constant, we can't add them up. Here, if you look at the question, the term with degree 1 is missing. After degree 2, there must be degree 1, right? That is missing. So for the missing terms, what we need to do is we add them as a 0 times g. This variable, now this is 0, so we can ignore it. If we add 0g, that doesn't make any difference over here. It's the same value. This is the same value, even if you add any number of 0g's. And then we write minus 9. So here it is minus 6, 0 minus 6 is minus 6g. And then bring this down, minus 9. And now you solve it up. You need to multiply how much? Negative sign is there. It means negative 2 times 3. So it will be minus 6g over here. And what about this? 3 times minus 3 is negative 9. Now when you solve it up, the sign changes. Cancels, 0 remainder. So yes, this is the answer. So this is how we solve them up. And last problem over here, please do try it by yourselves and then look into the solution set. So that's the end of this topic. I hope you found this helpful. Please do try to solve many more problems by yourselves. All these problems, whatever worked out, after watching the video, try them again by yourselves, because your exam questions will be similar to this, whatever is given over here. And if you have any doubts, any questions, please post them in the comments. And if you see some questions and if you know the answers to it, please do try answering your friends' questions. I'll see you all in the next video. Bye-bye for now. The 17th question is to solve polynomial equations by factoring. And here we need to use these two important formulas. Now these are sum and difference of cubes. You can see here there is a cube, b cube. It's not a whole cube. What is the difference in the whole cube? If it is a plus b the whole cube, we will have parentheses or brackets. But if the cubes are individual, you're cubed and then cubed, the formula is different altogether. Over here, it'll start with a cube, a power 3 plus 3 times a squared b, and so on. It goes on. From Pascal's triangle or binomial theorem, we can find it. But here, it is cubes individually added or subtracted to each other. So the formula differs, and these are the formulas. It is easy to remember if you know the pattern. Whenever there are sum or difference of cubes, remember you have to add them both, a plus b. If this is plus, it starts with the plus, a plus b. And then a square, ab, b square is there, but over here after a square it's minus. If you recall, a plus b the whole square is a squared plus 2ab plus b squared. And if it was minus, this would be minus, right? Similar to it, but there's no 2. But if it is plus here, already you're using plus, this will be minus. But if it's minus, you can see it's a minus b. And all these parts will be plus. A squared plus ab plus b squared. Please remember these formulas because they are very important to solve the problems. Now let's solve a few problems here. 8c cube minus 27d cube. So you need to make the whole cube over here. See, the constant is there, right? Now it's only this. This and this are two different things. If there is bracket, it's a whole thing. Parenthesis makes it a whole cube. And then we can use the formula. I can't use the formula like this. You know, I can't use the formula of a cube minus b cube. No, why? Because this entire thing is not cubed. Only c is cubed. So you basically have to take the cube root of this and then you can make it a whole cube. Same thing over here, take a cube root and then you can make this a whole cube. So how would you start solving this? Because I'm sure you may not directly remember the cube root of 8 and 27. Let's use our calculators to get those numbers. All I'll do is, see, look at this number 8, right? So I need to use cube root. Either you can press shift and this over here, x power symbol. And now you can type this 3 over here, cube root, and 8. Or I can directly press shift and you can see this over here, square root. If you press shift and this, it's going to be cube root. So that is 8. And now just change the number. Cube root of 8 is 2. And this is 27, that's 3. Now what we do is we just write them as 2c the whole cube minus 27d the whole cube. Okay, now we can factor them out. Sorry, it's not 27 over here, it should be 3 because the cube root of 27 is 3. If at all you don't get a whole number, integer, then you cannot solve this, then they are prime. Over here you can see right prime if they cannot be written in this form, but here you can. So let's write this out. Now we can use the formula. The formula is a cube minus b cube, that is equal to, since it's minus, first I write minus a minus b, then it's just a squared plus ab plus b squared. And now let me do over here, okay, let me write the direct substitution. A is whatever this over here, let me just change the color. See, whatever is over here is A and this over here is B. So what I do is, let me change the colors for B as well so you'll understand. This is B. So it starts with what? A, that is 2C. Then we go to B, that is minus 3D. That's it. Now look, we don't write the cube because we want only A and B. Whatever is inside the parentheses or the brackets is A and over here B. Now next thing is A squared, open the brackets, A squared, that is again 2C. Now how do you square it? Is it only to the C squared? Because I know sometimes students do this mistake, they write 2C squared. Wrong. A is the entire thing, so over here the squared will be again in the brackets. Now plus, just write again only A, that is 2C. And you have to multiply it with B. What is B over here? That is 3D. And lastly, we have to add it up with B squared, that is 3D the whole square, remember. So now this entire bracket is closed. You can see this is A squared, AB, B squared. Now the left side remains as it is. We can't simplify that. It's two different variables, 2 and 3. 2c minus 3d. But what happens over here is you square this 2c squared, it's going to be 4. The square is individually multiplied to both. Okay, it's 2 squared and c squared. And now this is the answer. If you had written in brackets, it will be 2c, but now we have removed the brackets. That means distribute this power to both the terms because they are multiplied. If it was added or subtracted, you had to use the a plus b the whole cube formula or a minus b the whole cube formula. But if it is ab the whole squared, this is simply a squared b squared. That's it. There's no formula. Whereas over here, if it's plus or minus, it changes drastically, isn't it? So this is the formula here, and over here, this is the formula. So since there is nothing, it's just multiplication, we write it like this. Then plus. Now what happens over here, it's just multiplication. 2 times 3 is 6. C times D is CD. Plus 3 squared is 9D squared. So this is it. And now you can, remove common terms. I think so. This is enough. Let's just check the answer because we have simplified it, factored it out. Yeah, that's it. Because you can't take any common. Say it's 2 is common in these two. 3 is common. We can simplify. We have used the formula. We have factored that out, and that's the answer. Let's do the next one as well. What we do over here is check for 64. It is 4 and okay, let me just go back. And over here there is no number, it's just 1. 1 cube root squared, anything is 1 itself, so no bother. This is 4, but the problem is we have x power 4 plus xy3. So there is no way we can factor out like this, isn't it? So what we do is, if we remove this 1x from both, then this becomes cubed, and over here x is gone, we have y cubed. It's all win-win situation, right? So let's remove this x from as a distributive property. It's gonna be 4 cube, x cube remains. Why? Because out of 4, 1 has gone out. plus this is gone, you're remaining with y cube only. So now if you multiply this back in, you're going to get the above equation. So we have done nothing wrong. If you multiply it over here, it's going to be 4 cube or 64, x to the power 4, because 3 plus 1 is 4. And over here, it'll be x times y cubed. So this is the thing. Now let's write it as a whole. X is what? 4x the whole cube plus y cube. And now we use, now here it was some difference of cubes. Now we have to use sum of cubes formula. Write it up over here. It'll be a cubed plus b cubed is equal to a minus b. See, sorry, it's a plus b. Whatever is over here, you start with that. Okay, and then over here it will be a squared minus 2 times ab plus b squared. See, over here, because it started with a cube minus b cube, minus is first. So this is how we write it. And now let me just write it out. A is this, b is this. So it's going to be 4x plus y multiplied with, so this is all multiplied. So 4x the whole square minus, okay, now wait a minute, I've written the formula wrong. I got carried away. It's not 2 times ab, it's a and b only. Okay, there's no 2 over here, it's just a times b. The 2 is only there in a plus b or a minus b, the whole squared formula. See, what I would suggest is during the exams, first of all, be thorough with the formulas, understand it. If you by heart them, you tend to forget and you tend to do mistakes. So get a pattern in your mind. Doesn't matter how many formulas, it just automatically comes to me now. That's because, obviously I've been teaching for a long time. But otherwise as well, when I was a student, I used to find a pattern among the formulas. And that pattern will, help you to remember easily. You need to figure out which helps you the best. So try to understand all this as a figure or something in your mind. Now let's continue over here. A squared is done, minus a is 4x times b is y plus y squared. Now another thing which students tend to get confused. So what happens is somehow they look at this, it's y cubed, right? So though they know that y is b, students write over here cube the whole square, or over here in the middle especially, they write this as cubed or something. Please avoid these mistakes. Though it is simple mistakes, students tend to do that. So that's why I'm repeating it. Now here, let's simplify how much we can. X as it is 4x plus y. And over here we have 16x squared minus 4xy plus y squared. And you can multiply this inside if you want. I think so this is fine. This is good enough. Let's just look into the answer, how much they have simplified. Yeah, that's it. So they have done only so much. We leave it over there. Now we will do the third question. In fact, I did this a while ago in the wrong type, and then I re-recorded it. I removed it because it's not that I was completely wrong. You can do that, but you won't be able to simplify to the fullest. It'll be more complicated. So looking at this, you should realize that you need to, do some simplification. You can see that a squared is an odd man out over here. So what we will do is we'll remove the a squared term outside and we will remain with a squared is gone. So it'll be from both of these 8 minus 2, that'll be 6 minus b to the power 6. Now we can't directly use a cube minus b cube formula. That is a minus b and a squared plus ab plus b squared. What we need to do is we need to get into this cubed, right? How do we get it? We need to write some power multiplied by another power. In the sense, imagine you have a power 4. You can write this as a squared the whole squared. Why? Because when you power the power, it'll be multiplied. Like 2 powers means it'll be a 2 times 2 is 4. That's how we get it, right? So now here, what are the two numbers when we multiply we get 6? It's either 2 times 3 or 3 times 2. So I can write it as a cubed the whole square. That is equal to also a squared the whole cube. It's a to the power 6. I can write any of this and get this, isn't it? Now choosing which one. Now the thing is, if you directly use the cube formula, here it's already squared. So it'll be complicated. In fact, you'll get a to the power 4 and everything, and it's very hard to simplify. So always in such cases, remember, you know there is this is difference of cubes, and this is the most appropriate way to use it, but inside. But there is squared outside, right? So do you know if we write like this, say a squared into a cubed the whole square minus b cubed the whole square, this is another identity now. That is a square minus b square. Do you know this identity? It is a plus b, a minus b. Now, if you use this identity first, then simplifying the above becomes easier. Now, how would you remember this? Always remember, it's better to put the higher power inside and the smaller power outside. Why? Because the simplification of squares, this is difference of squares, this is difference of cubes. The difference of squares is simpler. So now if you use this, squares at the outermost, we can use difference of squares and simplify this, and then we can use the difference of cubes. But if you do the other way around, it becomes more complicated, and this you cannot use it basically. I mean, you can, but it just becomes more and more complicated. So what we do is, as a thumb rule, try to remember whenever you have, say, 10. Okay, this is not a number, but it's better to write it as 5, the whole power is 2, the bigger power inside and the smaller power outside the brackets. I hope that is clear. So now what we can do over here is, I'll write it over here. A square outside, let it be as it is. But here, whatever is inside, first we have to use the difference of squares. It basically becomes a plus b. But what is a for us? Whatever is inside the square root, square, isn't it? So it's a cubed. Plus, what is over here? B, it's b cubed. And it's not over. Again, it is a cubed minus b cubed. So this is the simplification. Next, what do we do is, we have to use the sum and difference of cubes. So here a cubed plus b cubed formula is what? It is equal to, first we write plus, and then over here it will be minus. So this is it. So let's apply the formulas. Here we have a plus b, and then we have a squared minus ab plus b squared. And what about over here? It will be a minus b. Here it will be a squared minus ab plus b squared. So this would be the simplification. So that is how we can expand this. Basically, let's just quickly go back. First, use the difference of squares, and then what you do is you use the sum and difference of cubes and split it out. That's it. Within 4 steps, you can easily solve the answer. The detailed steps are over here. You first remove the square out and everything, and then finally get the answers. We can see this is similar to the previous one, but there is one thing I forgot to tell you in the previous problem. Here you can't use what we did just a while ago. You can't write this, say over here y cubed can be taken out common. You can't write it as x to the power 3 the whole square plus y cubed the whole square. Can you think for a minute why we can't use this? Because there is no identity for a squared plus b squared. There's literally no identity for this. Whereas there is difference of squares, that is a squared minus b squared is equal to a plus b, a minus b. It simplifies, but there's no identity for this. So if it is plus, we cannot use this. So we have to do other way around. Take the squares inside and solve it up. The cubes will be out. Use the difference of cubes formula, that is a cube plus b cube, and simplify it. But whenever there is minus, please remember whatever I told you just a while ago in this is only when there is minus. So whenever there is minus, have the cube inside, the higher power inside, then the smaller power. So we can use the difference of squares and then solve it up. But here, since we do not have the formula for plus, we directly go with the cubes because there is no other way, right? So we use the cubes, and now a is basically x squared plus y squared, x squared the whole square, and so on, because there wouldn't be any other method to go with. Similarly, you can solve these problems. Okay, now look at these terms. Over here there is 5, there is 18. There is no way we can get this as some number times x the whole cube, whole square or whole cube. Why? Look here, we need to write this x squared the whole cube. That's fine. But how would you write 18? There is no integer. Basically, there is see, it's not an integer that can be equal to the third power. So how do you check is, let's take our calculators. In this cube root, right? Just put 18 over here. It will never be a whole number. It's 2.62. It just keeps on going, right? So there is no way you can write this as a whole number or a integer the whole cube. And what about the other number as well? 5 also, it's not possible. See, there is no way. So therefore we call it prime. Even this one over here, there is 2. So there is no way we can do it. This is also prime. You can't use the formula over here. And okay, this is a different type of problem, similar to what we just now learned, but it varies depending on the number of terms. Can you see there are so many number of terms here, right? How would you solve it? There are different methods. Some would say, okay, look at the alphabet, first alphabet, G, G, group them, H, H, group them, and so on. You can see over here there are 3 x squares. So let's write them first together. X squared G x squared minus 3h x squared plus 6f x squared minus 6f y squared. Remaining is y squared. So let's write them together now. And 3hy squared. Now what I will do is, from all these 3 terms, I will remove x squared as a common term. Now what remains is, it's g minus 3h plus 6f. Over here, what am I going to do? See, you need to relate this, whatever you have got over here. Just look at this. You can see 6f minus 6f. Positive g minus g, whereas minus 3h plus 3h. So what I'm going to do is, I'm just not going to take out y squared, not plus y squared. I'll take minus y squared outside from these 3 terms. So these 3 are basically over here, and now these 3 are over here. When I remove minus y squared out, the sign changes for each term. And let me write first as g. What is this going to be? G term. Minus is gone, y squared is gone, you're just remaining with plus g. What about the next 3h term? Y square is gone, and from plus minus is gone, so it will be opposite sign, it's negative 3h. And what about this? Minus is gone, so it's plus 6f, y square is gone. Now you can see these 2 terms are same, this and this. Can I take this common outside? In the sense, from x square and this particular term, I can remove common. So how would I tell it better is, imagine this entire term to be u, and this is also u. So I can write this technically as, let me just write it over here. Instead of u, I'm just assuming this entire term to be u. Instead of this big term, I'm just writing u. It will be yu squared. Sorry, it's not y. It's u, only u, minus y squared u. So u and u is common because they are the 2 same things, right? So I will take u common outside. So I'm getting y squared minus x squared minus y squared. I hope this is okay. So now what I'll do is, I'll substitute what was u assumed to be. U was basically, it's g minus 3h plus 6f, isn't it? Let me just substitute it back. And what is remaining over here? X squared minus y squared. I can't stop it, it's nearly done, but I can see here it's x squared minus y squared, and we know there is a squared minus b squared formula. It's a plus b, a minus b. When they ask us to factor completely, what they are saying is basically to reduce the terms to the lowest degree as possible. If it's higher degree, it's complicated. The lower degree, the more better. So now let this term be over here, g minus 3h plus 6f. But here, instead of x square minus y square, I'll write it as x plus y, x minus y. And this is the most simplified form. You don't multiply these back. You're going to get this only, but this is the most simplified form. You can see that would be the answer, right? Yeah, it's x plus y, x minus y. And they have written first 6f plus g minus 3h. However you write it, it's fine. See, it's a writing exam. If you write so much, you will definitely get full marks. So that is how we solve that. And over here, another similar problem, not the same one. I'll do this one as well. Here, I would always go with x squares. Okay, it's up to you. You can try a, b, c. Okay, how about I'll change it now? Now I will go with a, b, and c's. So let me write a's together. It will be 12a's x squared minus 10a y squared. Then let me write b's next, minus 18b x squared. And then we have, where is b? Over here. Plus 15b y squared. And lastly with c, I'll write this first because 24c x squared is first and minus 20c y squared. Why I've written like this is when I remove things common out, the order is maintained. A x squared, sorry, A x squared y squared, B x squared y squared, C x squared y squared. It'll be easier now. Now, what do you remove common over here? You should try and see the maximum. I can't remove 10 because there are no 10s available both the places, but I can remove 2 for sure. If I remove 2 and this a's are common, if I remove 2a, what's remaining here is, it'll be 6x squared minus 5y squared. Now, if you multiply 2a over here, you're going to get the above equations. So now what you basically do is take two terms at a time. These two terms over here. Now let me just take the next two terms. Here, what will I remove common? I can see there is, I can take a number that is 3, right? Because 15 and 18, 3 is common. You should just know the tables. Or you should just try to find a number which is common. You should divide both and you should get a whole number. But for this, you should know the tables in your mind. Tables are basically like, 3 times 1 is 3, 3 times 2 is 6, and so on. If you know this in your mind, then you can easily get the terms in your mind as well. Now, whenever you're taking terms outside, right, remember to make the inner terms equal. See, whatever is inside the bracket. And that will happen. For such problems, that will be there. They will give you problems such that you will have common terms. So here, I know x squared and 6 must be positive. So if I remove 3 out, it's not going to help me. Why? Because it'll be minus, sorry, not only 3, 3b, right? It's going to be minus 6x squared, but I want positive, so let me take minus as well. So now what's remaining is 6x squared. Here it will be minus because it's plus, minus is out, 5y squared. And lastly, what do we have here? You can see for this particular term, it's plus, so that's fine. But over here, what do you remove common out is, you can take 4 common out. Because 5 doesn't work. 5 works over here and not in 24. 6 doesn't work in 20 and 24. But 4 works in both, isn't it? 4 6 times is 24. 4 5 times is 20. So I will take plus 4 and the c outside. And now what is remaining? Here it will be 6x squared minus 5y squared. This is what's remaining. Now you can see that these are all common, same. So you can assume this to be u and take the u out. It's up to you. Or you can just take this entire 3 terms outside. See, now if you're assuming this to be u, then you remove u outside and what happens? You're remaining with 2a minus 3b plus 4c. And then you substitute this value, or directly you can, you can directly solve it. How exactly? That is, let us just assume we are removing these terms outside. These 3 also are common, right? We remove it out. It will be 6x squared minus 5y squared. Okay, it's gone. So what are remaining inside the brackets? It will be 2a minus 3b plus 4c. Now if I multiply this inside, I'm going to get this term, then this term and this term. It's balanced, it's equal. I've not done anything wrong. I've just distributed them. I've manipulated them. That's the thing. If I use the distributive property, I'm going to get the above term. And even if I multiply it back inside, I'm going to get the question itself. So these three steps are enough. Now over here, I can't use the difference of squares. Why? Because here it's 6 can't be written as a square. So I leave it over here like this only. So you can see that's the answer. Don't go to simplify it further. So this is how we do it. If you're getting confused over here, take this as u, write it as 2a times u minus 3b times u plus 4c times u, and remove the common term u outside, and then finally substitute what you assume to be u as. That's how we can solve this. And over here, all these problems are solved in detail. You can see them. See over here, what happens is after you simplify, you have to use this formula as well, a cube minus b cube, which we studied, right? So apply the difference of cubes formula, and then you need to simplify further. I hope that is okay. And over here, you can see x squared minus 16x plus 64 is uh, completing the square method. Okay, so what happens is there's a completing the square method, but if you now it's a little bit difficult. Anyways, I'll just tell you that. Let me just remove it out. If you have terms like this x squared, we just now had minus 16x plus 64, I believe. We can complete this as a square only by knowing the first two digits. How we do it is this entire term, right? Whatever is this, we just write it as x, this sign as it is. Now this term will be divided by 2. 16 divided by 2 is 8, the whole square. And whatever is this over here, this number, doesn't matter plus or minus, just subtract 8 square. And what is remaining here? Plus 64. So this much is basically this much. If you now substitute, if you solve this up using the formula, you're going to get x squared minus 16. And now you simplify. Here, since this is a perfect square, right? What happens is, this is minus 64 plus 64. This cancels out and you're remaining with only so much. You will study this in the higher grades, I believe. I'm not sure this is done already for you, but this is the completing the square shortcut method. Now for your writing exam, if you may not get such big huge problems, where you have to use a lot of identities, but even if you get it, leave it as it is, x squared minus 16x plus 64. Leave it like this. That's enough. See, this last but one step is more than enough. Only if you can realize that this is okay, a perfect square, then yes, you can go ahead. Or you can also use your calculator over here. Since it's all in xxx, you can use mod phi 3 and solve it up and write it out over here. So that's also possible. And over here it's again similar. So you need to find some common terms over here, make them together. Over here all x are made together, over here all y's are made together. Now look here, you've taken the highest powers of x power 5, x power 4 and x cubed, and over here you can see there is common numbers as well, whereas over here other terms are taken, and then you remove the common terms out and try and get it and simplify it. Okay, these are now again a little different type of problems, so let's do one of this. Now you can use your calculator and solve it directly. I'll just show you now. You can use mod phi, and now don't go to 3, it's a quadratic, this is cubic, isn't it? Mod phi 4. Since all are a single variable, it's either x, x, x or a, something like that. You can use the calculator. The coefficient of a cube is 1, minus 9 and 14. And last term, there is nothing over here, it's 0. The constant is 0. So answer is 7, 2 and 0. You can see the final answer will be that. But how would you write this over here? So there are a few ways. Now, one trick way is from bottom you go above. So you know the answers. I'll write the answers. A is equal to 7, isn't it? And then there is 2 and 0. So let me write it. A is equal to 2 and A is equal to 0. So this is the thing. Now you can write over here up above, bring this inside. What happens? It becomes A plus 7. Sorry, A minus 7. A minus 7. and over here it will be a minus 2, and over here a minus 0 is just a. And then try multiplying these two binomials and write it upwards, because this is the answer. You're going up and up to this question now. A times a is a squared minus 2a minus 7a. This is just FOIL method, and plus 14, and this a is over here. Now simplify this. Let me write it as a squared minus 9a, 9a plus 14 times a. And now if I multiply this inside a, what happens? It's a cubed minus 9a squared plus 14a. So this is how you can go as well, and this is absolutely right, not to worry. Okay, or technically over here now, if I'm solving it, actually what happens is, this is the calculator method. You write the answers and then you build the above parts. So, some of the students would prefer this method because this is easier. You don't need to think of factors or anything. You can just keep on going up and you can solve it up. But when you're writing this, don't write this first and go down. No, that's wrong, because then obviously your teacher will understand you've done the calculator method, nothing else. But be a bit creative. Write the answers first, then go up, then go up, and then go up. I hope that helps you. I'll tell you how exactly you solve it. Here a is common, so we remove it outside. It will be a squared minus 9a plus 14 equals 0. And then how do you solve it further? This is a quadratic. You can find two factors. We need two terms which we need to multiply. See, 1 times 14. When we multiply, the answer must be 14, and when we add up, it must be minus 9. So 14, I can remember it's 7 times 2, because it's not a common number to have many multiples, many factors. So 7 and 2 I can easily tell, and it becomes 9, but it should be minus 9, so add minus and minus. That's the answer. So here what happens is, it'll be a, and the factors of this will be a minus 7, a minus 2. And then we write this all equal to 0, isn't it? This is all equal. Okay, I forgot to write over here. It should all be equal to 0, this entire terms. And now what we do is, we individually equate them to 0. A is equal to 0 first term. A is equal to a minus 7 is equal to 0 second term, and a minus 2 is equal to 0. So basically a is equal to 0, a is equal to 7, and a is equal to 2. You can directly write from year to year, that's also fine. So this is technically how we do it. And from here also you can use mode 5-3 and get the factors and solve it up to you. Okay. Now how do we do this one? First take it to the other side. It will be x cubed minus 3x squared. There is nothing over here, plus 0x plus 0 is equal to 0, right? Now let's take the calculator again and do the shortcut method. Press mode 5 and 4. It is 1 minus 3, 0 and 0. What's the answers? 3, 0, and that's it. So now in this case, right, if you have only two answers, see it's 1 and 0, right? You can't directly jump to the calculator method, because there must be three answers. One of this answer is repeated. So, there are only few problems which will come like this. So what I would suggest is, you have written this, right? X cubed minus 3x squared is equal to 0. If it's a big one, it's easy to solve from the method which I just showed you. But for such problems, take the highest common out. What is common here? X squared and x squared. So if I remove x squared out, what's the remaining? It's x minus 3 is equal to 0. Now looking at this, I can tell we got x is equal to 3. Yes. Why? Because we have to equate this. X squared is equal to 0 and x minus 3 is equal to 0, right? Here x is 0, x is equal to positive 3. These are the answers we got, but we didn't know which is having the squared repeated root. So now from this we can understand 0 is repeated. If we go from the answers to back, I'm not sure where to write squared, over here or over here. So both would be correct, right? But actually it's only for 0 that's repeated. So for such problem, when they are very simple, remove the common term and solve it up. Let's see one more of this problem, and you can see all the details are over here. The solutions are just 2 over here. And now for this, there is, okay, some of the latest model you can do this also in the calculator up to 4 degrees, but in most of the calculators, most of the students which use calculator FX plus, this is not there. Only cubed is possible, right? So what you can do is either you can take t outside, but since I can see t squared and t squared is common, what I would do is I'll take t power 2 outside, and what am I remaining with? T power 2 minus 3t minus 40 is equal to 0. Now use your calculator and factor these terms out. Let me show you. Please use more 5 and 3. 3 is for quadratic. And now what is before x squared? It's 1. And over here it's minus 3. And lastly we have minus 40. And the answers are, okay, it's just a bit loading. It's 8 and we have minus 5. So which do we write first? Don't directly write the answers. Write over here t square and write these factors. It will be t. We got 8, right? Change the sign and write it as a factor. See, it's t is equal to 8. T is equal to minus 5. But when we write it as factor, it comes in. So it will be t minus 8, t plus 5. I hope you understand that. So over here you need to write t plus 5 is equal to 0. Now use equation to 0 to all these. Now if you're thinking why I'm equating everything to 0, now look at this. This is a single term multiplied with this, isn't it? So imagine any three terms or numbers multiplied to each other and you're getting 0. So that means any one of this must be 0, otherwise you can't get the answer as 0, right? So you're trying to find out, it can either be t square is equal to 0, or it can be t minus 8 is equal to 0, or it can be t plus 5 is equal to 0. Any of this can be the solution to give us the answer 0. So we solve it up. If t square is 0, t is also 0. Square root on both the sides, you get 0 itself. This is t, 0. Now here take this to the other side, it's plus, it becomes minus, it becomes plus 8. That's also possible. And lastly, it's minus 5. So this is how we solve this problem. You can see the detailed methods are over here. It's 0, minus 5 and 8. Lastly, please do solve this by yourself. You can directly find the roots. Now here, since roots are repeated, right, don't go to do it directly. What you can do is you can take a common term out, b square. Now this can be found out. Here what happens is you will have a single root. That means it's a repeated root. So you write b minus 4 the whole square, because x and y, x1, x2 is not there, only x is there. Your answer is 4. So you just write b minus 4 the whole square and then solve it up. And so the solution is 0 and 4. If you directly put in the calculator also you get this, but since in writing, so you have to do the steps. And the last problem is a real world problem. A modern table is constructed with 4 legs made of concrete cubes with cube shaped notches. Define one or more variable and write an expression that represents the volume of one table leg. So let's do one at a time. This I'll do later. You can see this is a modern type of table, but they have tool, it's cube. So cube means it's all equal, but it doesn't look equal though. Please assume this to be equal, okay? This, all these sides are equal, and even the inside the notches which have been made, cube shaped notches, are also cube. That means all the sides are equal here. See that space which is cut. So we need to define one or more variables and write an expression that represents the volume of one leg of table. Okay, so we know this is cube. Now volume, let me just look at the answer, what exactly it is, and then I'll explain it. It's x cubed minus y cubed. Okay, I get it. Length of the side. Okay, so what we are taking over here is, let us assume the length of this cube be x. Okay, one of the side be x. So what is the volume of that cube? The bigger cube? It's x cube. Let us take this opened up, can you see the space which is opened up? This is also a cube, right? Let's take this side to be y. It's a smaller one, it's y. Okay. So what will be the volume if one side is y? It will be cube, because the cube volume is given by this x multiplied 3 times. That time it's volume. If it was area, just multiply 2 times, you get the surface area. Cube is multiplying by 3 times. So these are the volume. This is the volume of the cube, and this is the notch. How do we find the expression that gives for one column or the leg? That would be basically x cube minus y cube. Let me explain why. The volume over here, volume of this is of the leg, this is of the notch. Now see, the total volume basically is x cube, yes, but here you can see some of the space is removed, the notch is removed, right? So this is the volume of the notch, this is the volume of the entire cube. So the entire cube minus the notch would give us the exact value, exact volume. I'll write here. Okay, exact volume total minus whatever the hollow space, because when you're building it's not full, so that much is gone, right? That hollow space we have to remove it, so it's minus x cube. I hope that is clear. See here, that's how we get that expression. Now they have told Marisol determined that she will use 12,636 cubic inches of concrete to construct the 4 table legs. If the sides of the notch is this, are 40% of the sides of the legs, how long are the sides of the legs? Okay, they have given us the volume of she will use to construct the 4 table legs. So for 1 table leg, how much did we find the volume to be? It was x cube minus y cube, right? But for 4 it is 4 times. Okay, so much of the volume is how much? It's given as 12,636. They have clearly mentioned it over here for all the 4 legs. But the problem is we have 2 separate variables, we cannot solve this. But they have told the sides of the notches are just 40% of the total. See, now if this is say 100 units, the side of the notch is 40 units. So basically if this is 1, it's 0.4 over there. So what we will do is y will be how much? 40% of what? X, because x is this and this is y, so y will be 40% of that. So what I do over here is in x cube as it is, but instead of y I will write 40% or 0.4. If you put in the calculator, I'll write it as 0.4 x the whole cube. This all multiplied, that is equal to 12,636. Now basically you need to use your calculator and solve it up. Here this will be cubed, okay? So it will be 4 times. This is x cubed minus, what is 0.4 cube? It should be 0. I think so it's 0.64. So because 1664, yes, 0.64 x cube. I've just cubed it as 0.4 the whole cube, and over here x cube. That is equal to 12,636. And now we can easily solve it and calculate it. Take this to the other side, divide both the sides by 4, and then simplify this. Let's use our calculators now. Let me just one second just check this. I am sorry, it is not just 64, it's 0.64, okay? Because when you cube it, it becomes reduced, and yeah, 1 decimal moves to the other side. Okay, it should be 0.064, my bad. Now what I will do is 1 minus 0.064. So basically 1 minus the answer is how much? 0.936, right? So x cubed minus 0.064 x cubed would be, it's basically 1 minus this number, 0.936 x cubed. And what is this divided by 4? Let's do it in calculator. 12,636 divided by 4 is equal to 3159. So here it is 3159. Now divide both the sides by 0.3936. So what I'll do is I'll just divide this by 0.936. It's 3375. So we have to just get x, right? So x cube is basically 3375. Now take the cube root over here on both the sides. So that will be x is equal to how much? So we have 3375, right? Just take the cube root, shift and this with the answer which is saved as 3375. The answer is 15. So over here we get 15, and that's a real number. So many centimeters, or what is it? Which dimension? Inches, inch cube, right? So cubic inches. So inches is the dimension that is used. So the x value, the original cube, is 15 inches long. And the 40% of that, just multiply this by 40%, you're going to get, it's about 6 inches, I guess, the notches. And you can see over here, this is how you solve it. Okay, now what they have done is they have used, see, everything is correct. Now lastly, I've just directly used the cube root and I've taken the answer, right? But in fact, there'll be 3 answers, but we don't get the imaginary answer directly in the calculator. But I'll show you how you will get it. See, we got this term, x cubed is equal to 3375. Now you can bring this inside. It'll be x cubed minus 3375 is equal to 0. Now here, let's use calculator. Let's go to more, phi, and since it's cubic, let's go to 4. What is the coefficient of x cube? It's 1. But there is no x square and there is no x term, and there is only 3375. That is the constant term. Now if we solve it up, 15, yes, is one correct answer, but you can see there is imaginary numbers over here. So this is one imaginary number, and they are always conjugate or pairs. Imaginary number doesn't come as 1, it will come as 2 answers. So they are plus and minus. So that is the other answers. So we ignore the imaginary number. It's a real world problem. We have to have a real value. We ignore the imaginary part and take the real answer only. So that's how we solve this problem. That's the end of this topic, a very long topic. I hope you found it helpful. And a quick reminder, guys, if at all you have not yet subscribed to my channel, please do subscribe. It would mean so much to me. The question 18 is basically composition of functions. Here we have to add them, subtract or multiply or divide the functions. You will be given f of x and g of x. You need to find f plus g of x. What does this actually mean? Now here you can see it is f plus g of x. Which is the first function here? It's f of x, right? F. So it basically is f of x plus g of x itself. That's it. Now if you see this f of x minus g of x. Why it's very important, the positions? Because imagine you're subtracting. If you do g of x minus f of x, the answer is different, and f of x minus g of x, the answer is different. So please see which is the first and the second functions. Now let's solve this up. For adding, it's very simple. You should just add them up. Function f of x. See, now in writing exam, what you need to do is write this. It'll be f of x plus g of x, and then substitute what is f of x. It's 2x plus minus 4x plus 5. Here it'll be 2x minus 4x plus 5, and we will get 2x plus 5. If it is subtraction, it'll be same thing, but it's only minus over here. It'll be 2x minus 4x plus 5, and we will have 2x plus 4x minus 5 this time, and you can see it'll be 6x minus 5. Adding, subtracting is very simple and straightforward. What about division, multiplication? It's again the same thing. F of x multiplied by g of x, and now over here we have 2x multiplied by minus 4x plus 5. If you have thought, what if we write g of x times f of x, the answer will be same, but in a writing exam, make sure you write this. It's always the first function multiplied by the second function. So here 2x is multiplied, and it will be minus 8x squared. This multiplied here and here, distributed. So it'll be minus 8x squared plus 10x, and this is the answer. Now the last one is division. What does that mean is it's f of x divided by g of x. And we know f of x is 2x and it is minus 4x plus 5. What do we do here? This is it. We don't do long division or anything. We stop here. But there is a very important thing. Can you have any denominator of 0? When you make denominator close to 0, it becomes a huge number. Just do say 2 divided by 0.00001, which is very close to 0, right? You will have a huge answer. That means as you go towards 0, it's infinity. So it's undefined. You can't make this 0. So what we do is we will avoid it. We know minus 4x plus 5 cannot be equal to 0. If it is equal to 0, this is undefined. So let's solve for x now. Let's take the negative to the other side. It cannot be equal to 4x, and 5 by 4 cannot be equal to x. So basically we know that this can be the answer, yes, but x cannot be equal to 5 by 4, because if you put 5 by 4 here, what happens? It becomes 0. It will be negative 5 plus 5, it's 0. So therefore we avoid that. So that is how we solve it up. So you can see it is minus 2x plus 5, 6x minus 5. We got minus 8x squared plus 10x. And lastly, we got the same answer. Now here, instead of writing down, you can write it out over here, the negative sign, that's fine. But not equal to 5 by 4 is very crucial. So this is how we solve these problems. And they are all the same. Please do solve them by yourselves. You can see the detailed solution for each of these problems. So again, we have got a similar problem, just that when you write this, it's fine, but write this, it's not equal to what? And how do you do it? Just make 2x minus 7 not equal to 0. You can't have the 0, right? And then 7 to the other side, 2 divided by, it'll be positive 7 by 2. Even over here, it's the same thing. Now over here, since it's squared, when you multiply it, you will get cube. Okay. And okay, now this one, again, not a big problem, just same thing, distributive property. Adding, subtracting is very simple. Here, what you can do is, instead of, both the terms together, do this. And then this, distributed for method. So it will be 2x squared times minus x squared will be minus 2x to the power 4. Again, x squared will be minus 3x cubed minus 5x squared, and then over here multiplied by 6. 6 times 2 is 12, then 3 18 to 30, and write the variables. That's how we do it. But what happens over here? Don't worry, it's the same thing, but we have to make it not equal to 0. But there's a problem, it's a quadratic. So you can just put this in the calculator, because there are two answers now. Let's take our calculators. Here you need to see it's quadratic, right? So mod, this is an equation phi, and quadratic is given by option 3. Mod phi 3 gives you that. Or if you have a higher version of calculator, it's mod alpha and a over here. That time you'll get it polynomial simultaneous. Go to polynomial, select degree, and you'll get over here. The degree over here is 2. So now, first term, a is whatever is the coefficient beside x squared. It's 2. Then we have 3, and lastly we have minus 5. So remember, the order is x squared, x, and the constant, no x at all. So it's first 2, 3, and minus 5. And the answers are 1 and minus 5 by 2. So x cannot be equal to 1 and x cannot be equal to minus 5 by 2. Or means these two are not included in the solution. So this is how we basically solve them up. And here again, it's another similar problem. Please do go through it by yourselves. Here also, go to mod phi 3. You're supposed to get two answers. That is 4 plus 2 root 3 and 4 minus 2 root 3. Let me just show you in the calculator. Again, mod phi and 3 over here. And type this out. The coefficient, nothing means that's a 1. Then we have minus 8. And lastly, we have 4. The answer is 4 plus 2 root 3. Don't write in decimal. It will generally be in a fraction form like this. And then Okay, over here it is 4 minus 2 root 3. These are the two values to be avoided. They have written plus or minus because both are included over there. Now we have a real world problem. You can try these by yourselves before I start solving it. You can read them. You can pause the video now, read them, and try solving it. Here, Trevon opens a checking account that he uses only to pay fixed bills, which are expenses that are the same each month, such as car loans or rent. The checking account has an initial balance of $1,750 and Trevon deposits $925 each month. The balance of that account can be modeled by A of x, that is 175, that is 1750 plus 925x. Now, to write this equation, it will be given, but let's understand what it is. This is the amount which is already fixed. He has initial balance. It does not change. That is over here already there. But every month he's going to deposit how much? 925, right? So x means after 3 months, all you need to do is if you put x of 3 and you solve this, you will get the amount of money he has after 3 months. That will be 925. 3 months is deposited. So if it's 1 month, just put 1 and so on. So that is how we get this equation, where x is the number of months since the account was open. The total of Trevon's fixed bills are modeled to be 940x. Now here, how much is depositing? 925 every month. But his bills, say his rents and loans and everything, is 840 every month. So over here, this is the difference. So he's putting more, that's fine. 60 is 85, the $85 more is depositing, that's well and good. But here, this is the equation given. X means for every month. Define the graph of the function that represents the account balance after he pays. Now first, let's write over here the first A1, identify and write a new function that represents the account balance. So whatever money has put, some money is deducted as well, right? What is exactly happening? Over here, to understand how much money is left in that account balance, we have to do A of x, what he has, minus the bills, that is B of x, bills are removed. So this is it, this is the function. So it is A minus B, the whole of x. You can write it like this as well, composition of functions. And now your first one is 1750 plus 925x minus 840x. So it is 1750 plus, it was 85x. So this is the given function. So that is the part A, combined account balance. You can see it is, okay, you can write 85x first, that's fine. And this is the answer. Now, what about the other one, graph? You should just graph this out. You can use the table method or whichever method is possible. Here, let me just tell you about the graph. Now, what we got over here was 1750. There is no x. That is the intercept. So initially, there was so much money. There it will start the graph. Now, this 85x is what's happening. The graph is, it's positive, right? The slope is upwards, positive. And here, if you take a slope, then you will get 85, positive 85. Now, basically your positive 85, that's the slope throughout the function. How would you do it is, you can choose, say over here, you know the intercept, and after 5, that means after 5 slopes, so it is, how much was that equation? 1750, over here there was 85x, right? Put over here x as 5, whatever answer you get must be plotted over here, and then draw a straight line. But I will tell you how to do the table method, which is very easy. You'll get a lot of points in that, but you need a calculator for that. You need to go to mode, and then you need to press the table option 7, and over here we get the function. Now what is the function? It was 85x plus 1750. You can even write 1750 plus 85x, the answer will be same. You may not get this option, but if you get this option, just ignore it. We are just graphing one equation. And now where do you want to start? So the start and stop is basically the x values. So now see, it's about months. I will have to start at 0 or 1. I'll start at 0. And let me end it at, say, I don't want all the months, just a graph of like 5 to 10 months is enough. I'll take about 8. And what is the step? Step means See, I took 1 to 8, right? How do you want? Every month do you want means 1. So it'll give me 0, 1, 2, 3. If I put 2, then it'll jump to 0, 2, 4, 6. You can jump as well, but let me take over here for now step as 1 and I get the value C. At 0, it must be 1750. Okay. At 1 over here, it should be 1835. Let's see. 1835. Yes, it corresponds somewhat there. 1920 at 3, yes, and then we have at 3 as 20. It's very close to 2100, means it's 2000, and then over here it's 2090, so it's almost close to 2100, and you can see the other values. That's how we plot them from here. Now this scale is very important. Now what I would do is, generally, because we have a jump of 1750, 300 is reasonable scale. I would have gone with 250 because it's much clearer. 250, or here they have taken 300. Yeah, it's fine. Even you can go with 500, but you need to make lot of see, lots of values will be very close to each other when you plot, because if it's 500, so better to go with 250 or something reasonable. And over here it's the same thing, I believe. Yeah, the total cost. So you just basically subtract them, sorry, add them over here. Why? Because they have told t-shirt and game jerseys, the coach t-shirt has so much cost. Okay, and over here there is another cost. This is another cost, the online ones. You add them up. If you read the problem, you'll understand there are two costs. Now imagine you're buying something from a store, buying something online. What is the total cost? Add them up, right? So you add them up and you get this answer. And now you graph it just like we did it. So the intercept is 55 and there is 25.5 depending on the number of people, team members. Now we are the scale you can keep as 0 to 10, and you can give the jump of 1 only. And over here, take a reasonable scale. 50, 100 is much better because it's at 55 over here. Now, this is another type of problems. Let's look into this. The National Center for Education Statistics report data are showing that since 2006, college enrollment for men in thousands can be modeled by this function here, where X represents the number of years since 2006. Similarly, enrollment for women can be modeled over here. Write a function f of x plus g of x and interpret what it says. So now they have just told us to add these two functions. Okay, let's add them up. You have to just add 280 plus 389, 750 plus 10,075. So this is it. Now they want to know what it says. That means it's the total enrollment. Now, every year from 2006 there is an increase in the student male and female by 869, and at the 2006 there was already 17,575 students. The function represents, and okay, they have just told that much only, but you can tell more. Basically, what is this x? X means every year that is changing. This is the intercept. Already there were there, so many students were there, and then next year it's becoming more and more. So basically both men and women. And now over here we have a table and we have been told to solve these functions. This is also again an easy one. So now you have not x or y, it is in terms of -1. What does this mean? This basically means f of -1 plus g of -1, isn't it? What is f of -1? We have the function of x over here and -1, 0, 1. So what is f of -1 exactly? It's 7. What is g of -1? It's -3. So 7 minus 3 will be 4. So that is the answer. Here you have h of 0 minus g of 0. So what is h of 0? It's 4 minus of -4. So it will be minus and minus will be plus. It will be 8 as the answer. Now we have multiplication over here. F of 4 times h of 4. F of 4 is 1 times h of 4 is 5. The answer will be 5. And division, let's do this one. G of 1, where is it? It is -5. I've written directly above, it should be g of 1 divided by f of 1. Okay, -5, what is f of 1? 0 multiplied by 0, so the answer is 0. You can do the others by yourselves. So it's 4, 8 minus 5. This is pretty straightforward. It's 4 divided by 1. 0 divided by 1 is how much? Oh, sorry. I have done a mistake in the last one. It is 5 minus 5 divided by 0. Okay. So it is basically g of 1. Let me write it properly. And f of 1, isn't it? It is g of 1 minus 5 divided by 0. This is undefined. It cannot be. It's wrong because the answer will be towards infinite. It can be anything. It's undefined here. So you can put minus 5 divided by 0. You get math error in your calculator because it's undefined. But you can divide anything by 0. So 0 divided by any number is 0 itself. Okay. So this is fine if 0 is in the numerator, but it cannot be in the down part. Denominator not allowed. So that's how we solve those. And here they have asked you f of, okay, find these terms. Okay, this is interesting. Why? Because they have given us the answers and told us to find the functions. So f of 3 plus g of 3 is equal to 5 is known in the first equation. And what is known over here? F of 3 times g of 3 is equal to 6. Okay. So we need to find these two functions, isn't it? Now I can get one function as another. Generally, such problems are written as a, b, or x, y, and solved. So let us take f as x and y, g as y. Okay, it'll be easier. X plus y is equal to 5. Here, x times y is equal to 6. Now let me take this y to the other side. It will be x is equal to 5 minus y minus. Here we know it is x multiplied by y is 6, right? What I'll do is instead of x, I'll substitute this 5 minus y into y is equal to 6. Now I got everything in one variable. Let me multiply. 5y minus y squared is equal to 6. Let me bring it all inside. It will be minus y squared plus 5y is equal minus 6, sorry. Minus 6 is equal to 0. You can leave it like this or change the sign, it's fine. Now to find the y value, you should use your calculator. All you do is mod and 5 and 3. And the coefficients are minus 1, 5 and minus 6. The answer is 3 and 2. So now this over your y value can be two possibilities, right? So let's write it. Y is equal to 3 and y is equal to 2. So let's solve x for both the cases. If at y is equal to 3, x is equal to 5 minus 3, that is what? It's going to be 2. At y is equal to 2, x will be equal to 5 minus 2, that is 3. So the answers over here will be a f of 3 is equal to, you can x value is equal to 2. That time g of 3 is equal to 3. And f of 3 is equal to 3 when g of 3 is equal to 2. So these are the two possible solutions. I hope this is clear. And one quick thing, if you want to go out of this mode, I hope you know you can either clear your calculator or press mode and 1, computation mode. You'll be back to computing mode. Now these are the answers. You can see here the solutions. Two solutions are f of 3 is equal to 2 and g of 3 is equal to 3, and over here f of 3 is 3 and g of 3 is 2. So that's how we solve this problem. You just can write what I have written over here like this. I've taken x and y, that's fine. They have taken over here a and b, that's also absolutely correct. Now we have an interesting problem here. They have told write two functions f of x and g of x, like two functions. Now I will take a random function, say for example x plus 2, and over here I'll just take x minus 2. Okay, I'm not sure whether this will satisfy this, but anyways, we need to find the composition. Remember, this is not multiplication. F of say f whole g, this is f composed g, is not same as this one. Till now we saw the dot. This is what? F of g of x. It's composed within each other. There must be x and x over here. Now here this is just multiplication, so you multiply them both, and composing them and multiplying is two different things, so please be careful with this. So what happens here is, now 4 I will add it at the end. Okay, let's do that at the end. Now for now, how we compose it is f of g of x, two brackets to close, f of, instead of x what we have is g of x. So what is g of x? Goes instead of x here. So I don't write x, I write x minus 2, and then what is remaining is plus 2. This is how we do composition. And now let's solve it up. It will be x minus 2 plus 2 is 0, so it's x. Now this is g of x, okay? But we need of 4, right? Composed of 4. So you can either write this or you can write it like this. Both are same thing, okay? So I'll write this given function g composed of 4. The answer is 4 now. Sadly, this doesn't satisfy. We have to make it 0. So now you need to find a relation. If I take, you can assume one thing, whatever you want, f of x. What must be the other thing? So here, if I have to get this 0, what should I have been over here? If you, like, see from the answer, you can go back. There must be minus 4, right? There must have been a minus 4 over here. Then I will substitute x as 4, it becomes 4 minus 4 as 0. If this should be minus 4, what should be over here? Like here or over here? It's up to you. Now since g of x is substituted, what I'll do is I'll change this. It's much easier, right? If this has to be minus 4, I have to add minus 4 here. So what happens if this is minus 4, it will be plus 2, it will be minus 2. So if at all I add this as minus 2, what's going to happen now? Let me take it. 4 plus 4, it will be minus 2. See, just solve this up. If it's minus 2, yes. So don't worry about this function, leave it, only these two. See, plus 2 minus 4 is minus 2. And now let's solve them up. If I have x minus 2 here, I'll erase this all. Over here it's minus 2. Now can you solve it up? It's going to be minus 2 minus 2. What happens? It'll be x minus 4. Now substitute 4, it will be 4 minus 4. That is 0. So if you have two same functions, yes. But now what if they don't allow for same functions? If they have mentioned, this is possible, okay? If you have two same functions and you composed, you will get, when you substitute 4 over here, you'll get 0. But what if they don't allow you two same functions? You need to have something else. Now we will just change the value of f of x. Now what I would suggest is, take a bigger value of 4. Okay, I will take f of x, say plus, or you can take minus, then the other one will be plus. I will just take this as 8, plus 8. So what happens is this g of x must have a difference of 4. Now I will tell you why. Because imagine it is anything, the g of x is anything. When you compose it, this is g of x, it will be this term, right? It's plus 8, and this term becomes x some number. What is the number I should have over here? We just now saw, right? It had to be difference of 4, right? This finally it should be minus 4. So over here, if you have, say, minus 12, 4 more than 4, but negative sign. See, it should be x, 4, add 4 to 8, it will be 12, but the sign must be minus. Why? Because we need negative 4, right, at the end. Now what happens is, it will be x minus 12 plus 8, that is x minus 4. Now you substitute over here g of 4. When you substitute, it will become 4 minus 4. The answer is 0. It is satisfied. Now why I did this is, see, the first one is also correct, but that was same numbers. If they ask you specify, take those two separate numbers, then these are the answers. You can even change this, say, over here you can make it 5, and this will be minus 9, it will work. Just make sure there is a difference of 4. If this is, say, I can even take like this. We will take addition of one term, see, 1. Then add 4, it will be 5, right? But it should be minus. This is it. That's the relation. And let's see over here what they have done. See, over here they have taken minus over here, minus 9. But now there must be opposite sign. See, if this is minus, the difference must be how much? Minus 4. How will you get it? If you add 5, right? You can't subtract. That time I had taken positive first, so I was telling difference of minus 4. Basically, when you add these two numbers, you must get minus 4. Another way to understand is you can assume anything over here. If you take, say, x minus 9. This will be unknown. What is it? Minus 9 plus unknown value. Say block must be minus 4. That's it. Because over here it's plus 4. It will be 4 minus 4. That's the answer. So what is it? It should be 5. Minus 9 plus 5 is plus 4. You can put this in the calculator and get that value. So I hope this is clear. It's a simple one. We're going to the end. Over here they have told Chris and Tobias are finding composition of the functions where they have given these values. Who is correct? Let's see both of them. Let me do it first properly, okay? So f of g of x, what happens is, now this function goes inside x. Wherever x is there, it must be put over here. So instead of x square, I will have to write x square plus 8 plus 2 times. Instead of x, I write x square plus 8 minus 8. Now we solve it up. Okay, this is going to be a big one. See, now since we are not going to solve it, it's fine. But, we are just correcting, so it's fine. But otherwise, how you solve it is a plus b the whole square formula. It is a squared plus 2ab plus b squared. We have to apply this identity because why? It's a plus b whole square. Let me write it properly here. So that is why we have to use the identity. There is no way you can just square them all. Like, don't think, oh, I will just x square square, it's x power 4, 8 squared. No, you have to use the identity. It will be x squared the whole square, because we already have square. A is x squared whole square times 2 times x squared multiplied with b is 8 plus 8 squared. And over here it's very simple, it's just distributive property. It will be 2x squared plus 16 minus 8. Now here it is x to the power 4 plus 2. 2 times 8 is 16. X squared plus 64 plus 2x squared plus 16 minus 8. So add them all up, it will be 16 plus 8 only. That's going to be 72. So x power 4 plus 16 plus 2 is 18x squared plus 72. This is the final answer. And I can see that Tobias did it correctly. Now, what mistake did he do? Explain your reasoning is there. Okay, he has done this. You can see here, this 2x, we have to substitute. See, I did over here, instead of x square, I put this as the whole square. Then 2 of this x. It doesn't remain x. You have to substitute this x squared plus 8, right? That is the mistake. Okay. See, you can directly look into both. It was the first step only. What if it was a long problem? It's somewhere down. So it's better you solve it by yourself and then you can easily tell which is correct. I hope that one is also clear. And Tobias is correct. Chris, what he did was he did not substitute g of x for every value of x in the function f of x. That's the thing. We have another interesting problem. Here we have to multiply, not compose. See, this is whole, not sorry, it's a point, right? Not a whole. Whole is composition, point is multiplication. Now here g of x is multiplied to, both of them are multiplied. So what's the answer? It is basically x to the power 6 multiplied by root of x to the power 6, right? It's x to the power 6 only, square root cancels, right? This becomes whole. Now, otherwise, if you're getting confused like this, you can just write what does the square root means. It is power 3, and this is how much? Again, we have 6 by 3. So, sorry, this is 2, not cube root, it's square root, right? It's always 2. Okay, this is 2 divided by 2 divided by 2. So you can solve them up. 6 plus 6 divided by 2, because the denominators are same, add the numerators. So you will have 12 divided by 2, and that is x to the power 6. That's it. Over here it is cube x to the power 3 square root of that. So it's gonna be like this. So you can just cancel it off. If you think practically, now I have x cubed. I need to split it out into 2. So I can do this, right? So the same thing what has been done over here. So what we do is here x3 of half times x3 half. Whenever you have a square root, it's if you have just like this is x half, power half. If you have cube root over here, then it will be 1 divided by 3. Whatever for the radical symbol, it will be divided. Now this is basically x power 3 only. Now I've just erased all this. I'll write the answers directly. F of x has been multiplied over here. It's cubed. Over here, what happens? It's 6. So now we need to find the domain. And we need to think whether it will satisfy the above conditions as well. Now here, what happens? X to the power 6, right? You don't need to solve these, to be very honest. This is not even required. I've just done it over here because they have told. I just realized the question is only to determine each domain, not to solve them. Okay. The domain, what happens is, here let's first do g of x. Doesn't matter what, we have an even power. So imagine you have taken, say, value of -3. When you power it to the 6, I am not sure about the answer, it'll be more than 247, but the answer will be positive no matter what when it's an even power. If it's -3 the whole square, it's going to be an even power. It's going to be positive 9. 4, it's going to be positive 243. It will be positive, positive. Whenever there is even power, it's positive. But when there is odd power, say you have 2 to the power 1, -2 to the power 1. This is just -2, right? Say you have -2 to the power 3. It's going to be 3. This is okay. It's going to be 8, yes, but it'll be negative sign. Why? Because -2 times -2 times -2. This will be positive 4 times -2 will be -8. So this is negative. Whenever you have odd powers, negative sign sustains or remains. So the first domain, since it's having even power, it's all real numbers. The domain is all real numbers because even if it's a square root cannot have minus over here, right? Doesn't matter. Whichever minus or positive, because of this even power, it will only become positive. So here all real numbers are possible. Whereas, what about this? Here, no, we cannot take all real numbers because if you take minus value for x, it will remain minus and becomes imaginary. So it should be only positive real numbers, positive real numbers. Okay, NOS numbers. So this is the answers. For the first one, it's all real numbers are the domain, and next one it is only imaginary, all only positive numbers. See, all real numbers means minus infinity to infinity. Positive numbers means anything greater than 0 till positive infinity. That's the answers. So we are in the last problem here. We need to state whether the following statement always or never true. Justify your argument. The domain of two functions f of x and g of x are composed of g of f of x is restricted by the domain of g of x. Okay, I don't think so. See, we just now saw some problems, right? Over here, the domain sometimes is not restricted, sometimes it is. So it is, you know, doesn't. Okay, let me just take, because you need to take an example problem and solve. I'll just show it over here. See, sometimes it's true. It's not never. It can happen. Look over here. One domain was different. One domain was, all real numbers. One there was restriction. One there wasn't. So what it means is, now this is multiplication, but still, here when we compose as well, look at this here. See, when imagine you have taken a function f of x and g of x is root x, because root x are the only ones which will restrict, right? Now put it over here. Over here, instead, how we are composing? We are composing g of f of x. Now instead of x, what do you put? 4x. Over here you put. Now yes, the domain of g of x is what? Square root. This is restricting. Why? Because x cannot be any negative numbers. It should only be positive real numbers. Yes. But the same thing, imagine you had a square over here. X was positive power. Over here, if it was odd number, if it was x power 3 as well, you have issue. Why? Because square root of x power 3, x power 5, or any odd number, odd powers, the domain is restricted by this function square root. But same thing for even powers, it doesn't have any restriction. Over here, all real numbers, right? Why? Because it doesn't matter which, it'll be a positive, so square root, it's fine. You will never have undefined answers. So in this case, the domain is not restricted when it's even power. So we can't tell it's always, it's only sometimes that happens, okay? Sometimes the square root will restrict it. And that's the end of this topic, another long one. I hope this is helpful. Please do try to analyze these problems thoroughly after watching the video or during watching the video. Solve them in writing. Please note down the steps, write it in steps, and be thorough with these problems. The question 19 is to expand powers of binomials, and we use Pascal's triangle and binomial theorem for this. Here, first, let's look into Pascal's triangle. Now, before we see what Pascal's triangle is about, I'm sure you know the expansion of a plus b the whole squared. It's very easy, right? It's a squared plus 2 times ab plus b squared. Do you know what is it for a plus b the whole cube? I hope you know it because you have to remember this as well. You had it in the last term and even in this term. So it's a cube plus, now over here it becomes 2 times a square b plus 2 times ab squared plus b cube, isn't it? Now how did we get this? Okay, this is anyways, if you remember the identity, it's okay to memorize. But what if I give you a plus b the whole power 6? To be very honest, I don't know how to expand this in my mind. I know it starts with a power 6, over here also it's b power 6. And there are a lot of middle terms in the middle. So what about these? This mathematician Pascal came up with a triangle. So he found out the pattern between all the binomial powers. So you started with 1. He starts with 1. Let me write it over here somewhere. 1. And then you expand it as 1, 1. And then you go away 1, 1. But now you have 2 terms over here. So you add them up. 1 plus 1 is 2. Now always the ends are 1. So now here you start with ends, yes, but there is an addition over here. 2 plus 1 is 3 and 2 plus 1 is 3. And now I just realized one thing. I wrote this as 2, it is 3 and 3. My bad, I apologize for that. It is a cube plus 3a square b plus 3ab squared plus b cube. So this is the formula. And next one, it'll be 1. Over here it'll be 3 plus 1 is 4, 6, 4, 1. And this keeps on expanding this triangle. Just 1 and add this, 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 and this. Now what are these numbers? These are basically the coefficients when you expand this binomial power, right? The coefficients of each terms are given over here. So these are just the coefficients. But how do we know what is this a cube or a square? So now let's just look into the triangle, a big one, okay? Over here you can see this one, 6th row. So what we basically do here is, you start with what's the power? This is 6th row, that means it's a plus b the whole cube. Oh, I forgot to tell you one thing. You start with 1, that is a plus b the whole power 0. That is what, anything raised to the power 0 is 1, right? So that's it. And now what about this? A plus b the whole power 1. The coefficient is 1. You start with a plus 1b, that is a plus b itself. Because anything raised to the power 1 is the same thing. Now this is a plus b the whole power 2. That means it's a squared plus 2 times ab plus b squared. Here you can see the power plays an important role. First term, the coefficient will be always a and raised to this power. Next, what happens is, this reduces by 1, the a power 2 reduces by 1, and the next term is added like b. And then over here, b the highest power, because a is power 0. Now here, if you're looking at this, it's power 6, isn't it? So you start with a power 6. Next one will be a power 5. It'll be power 4, a power 3, a power 2, a power 1, and this is a power 0. We don't write it because a power 0 is 1. Now here, other ones are b power 0, 1, 2, 3, 4, 5, and lastly the highest degree is 6. So the coefficients are given over here, and this is the variables. It will be 1, a power 6 b power 0 is that's it, plus 6 times a power 5 b, plus 15 times a power 4b squared, plus 20 times a cube b cube, and so on. This is the coefficient and these are the variables. Write them up together. So that's how we expanded. So this triangle was given by Pascal and we call it Pascal's triangle. And this is the expansions. You can see over here 1 x power 5, 5 x power 4, and 1 just begins because it's 1 power y power 1. And next one, it will be x power 3 reduced 5 4 3 2 1. Over here it's y 0, which we don't write, 1 2 3 4 5. This is how we do the Pascal's triangle. Now we will look at an expansion of a problem. For the exam, since it's in writing part, what I would highly suggest is you guys just can make a, like a triangle. This is easy, right? 1 1 1 1 2 1 1 3 3 1 1 4 6 4 1, and then 1 5 10 10 5 and 1, and this keeps on going. You can see here there are various ways to remember. This is 0 starting 1 2 3 4 5. The easiest way to remember is after 1 look at the number. See, this is 2, right? That means it's power 2. Now this is 5, that means it's power 5. Now a power a plus b the whole power 4 will be a power 4 plus 4 a cube b plus, and then over here you should know these. It'll be 6. You can think in your mind, but it's, the Pascal's triangle helps a lot. And since it's writing, I would highly suggest you to do this anyways. For these type of problem where they have clearly mentioned, use Pascal's triangle. Now this is 6, 15, 20, again 15, 6 and 1, and lastly we have the 7th power, that is 1 7 21 35 35 21 7 and 1. Now this is the final one. Now if you do so much the triangle, it's not that difficult. Directly write it out. Now it'll be first term. What is the first term? X power 7. Next one, what happens? It'll be plus 7 times x power 6. What is the a or a plus b, right? What is the b term? It's 7. Now 7 power 1. Let's write it like that. Plus, what about this? 21 is the coefficient, x power 5, and we have 7 power. This was 1, it becomes 2. Plus 35 x power 4, 7 power 3, plus again 35 x power 3, 7 power 4, plus 21 x power 2, 7 power 5, plus 7 x power 1, that is only x, 7x, and 7 power 6, and lastly we have 1 into 7 power 7. So now these things can be put in the calculator, 21 times 7 squared, everything, all these huge numbers, and then you get the final answer. Let's quickly look over here. You can see this is the Pascal's triangle. So these are the terms. And now we have this, whatever I just now wrote is written over here. If you look carefully, it's x power 7, 6, 5, 4, 3, 2, 1, and 0. And over here it's 7, 7 squared, power 3, 4, 5, 6, 7. And the coefficients. So if you're getting confused to write directly, what I would suggest is you get this right over here. So don't write x over here, write x, x squared, x3, x4, x5, x6, x7. And then what about 7? Over here you don't write 7. Sorry, over here I have made a huge mistake. This should be 7, not x. Okay, I'll just erase it. It's x always. The first term starts with the highest power. Okay, it is x power 7. Then 6, 5, 4, 3, 2, 1. That's it. And 0. Now what about 7? It's 7 power 0. It's 1. So I'll leave it. Then multiply this by 7. 7 power 1. 7 power 2. 7 power 3. 7 power 4. 7 power 5. I have made a mistake again, a silly one. This is 1. This should be 2, 3, 4, 5, 6, and 7%. There was a comedy of errors which I did. I'm sorry for that, but this is the final answer. Now, once you do so much, if you have written this thoroughly, you'll get most of the marks, but still it's not completely simplified. Just use your calculator. This remains the same. 7 times 7 is 49. 21 times 7 squared, that will be 49 times 21 is 1029. And same way, you need to solve all the numbers and you'll remain only with the variable x, x to the power 4, x power 3, and so on. So this one is 7 power 7. Now this is same. Why? Because 7 power 6 times 7 is 7 power 7 itself. So this is how we solve by Pascal's triangle. It's an easy one. It just takes time. And with practice, you can write it very, very quickly as well. So please do try these problems by yourselves. Now, since it's just power 3, it's a very simple one. 1, it starts with 0, 1, this is 2, and 3. You can, even if you know the formula, you can directly do it, but it's better to do the Pascal's triangle. That is the concept here. Now, what you do is, it's 1, and 3, and 3, and 1. These are the coefficients. First, I will start with x. Look, x is positive, right? So I'll just write x highest power. What is it? 3, x power 2, x power 1, x power 0. You can write it anyways, it's fine. And what about y? But don't forget just to write y. It's minus y. This is power 0, minus y power 1, minus y power 2, minus y power 3. And all are being added up together. See, don't think, okay, it's minus, so this is minus. No, the minus will be inside the bracket for y, and then the power is outside. Now let's simplify. 1x cube and this minus y the whole cube. Doesn't matter what you take to the power 0, it's always 1. So 1 and 1, it'll only be x cube. What about the next term? Here, minus y to the power 1. How to check whether it's positive or negative? Just put in calculator, minus 1 the whole power 1. You'll get minus 1, right? That means this will be minus y here. So this plus and minus will become minus 3x squared y. What about over here? It's y squared. If you try minus 1 the whole square, it is positive 1. So if it's positive 1, that means this term becomes positive. So you are getting positive sign here. 3xy power 2. What about the last one? It's power 3. Minus 1 the whole power 3 is negative 1. If you're getting confused, use the calculator and check this. And now x power 0 is 1, 1 is 1. And lastly, this plus becomes minus y to the power 3. So this is the final answer. So this is how we do it. Please remember to write the Pascal's triangle and then get the constants and then substitute it. It is not that difficult. You can see the expansion over here. So it was minus plus minus. That's it. Now, you don't need to write all this. This is just extra detailed explanation. What I would highly personally suggest you is do this Pascal's triangle, get this coefficient, so write this over. This is your answer. And you know, they won't give you a huge power. They won't give you like powers like 10 or 9 or something. In your exam, you might get anything less than 5 because you know the concept is same, but it just takes time, you know, calculating. So reasonably 4, 5 is maximum they can give you. So this is how it is. Now this one is again the same type of problem. Please do it by yourself and then you'll get it. Just see the Pascal's triangle and look for the coefficients. Now here, if you just expand this Pascal's triangle, you will get 1, 4, 6, 4, 1. You can see here it's 1, 4, 6, 4, 1. And this one as well, but over here it'll be negative sign, so it'll be negative, positive, negative, positive. And if it was another term, it was power 5, there'll be negative, positive, negative, positive, negative. It's kind of like that. And these are again the same ones. Please solve them by yourselves. And this is a huge one. You know, there are many terms, but don't worry. Hopefully in exam it'll be a simple one. Even if it's a big one, it's just that you should do Pascal's triangle till there and then take the coefficients and solve it. Now we move on to binomial theorem. I hope you remember this formula. Pascal's triangle was done before binomial theorem. The binomial theorem worked on the drawbacks of Pascal's theorem. So now if I just tell you, say, x plus y, the whole power, say 15. For Pascal's triangle, you should start writing 1, 1, 15 times. That's such an onerous task, isn't it? So what's the better way? The binomial theorem gets rid of that. It doesn't make you do all the terms. It just needs the power. Which power? and it'll directly give you the answer. So the formula is like this. You start with combinations over here, NCR, you know this NC in probability, you might have come across it. You can use it directly in the calculator, so don't bother. You can know the formula, it's a very simple formula as well. It is n factorial by r factorial into n minus 1 the whole factorial, n minus r the whole factorial. But even now, this is written as 1 because this is 1. Really, it's ncr. That'll be r and r. That's the formula. Even if you do not know the formula, we can do this in calculator. But now, what's the formula? So if you have a plus b the whole power n, this will start with nc0. Now this r is specified with values. You always start with 0. And the first term, A will be the highest degree and the B will be the lowest one. That is what we did in Pascal's triangle as well, but it was not formulated exactly. And next one, it is NC1, A. Now N minus 1, the A power, the first term reduces, whereas B increases by 1. Same way it will be NC2, A, N minus 2 and B power 2. This continues, it keeps on continuing till when? Till you reach the given degree. If it was phi, till you reach NC phi. But the better way to write it is NCN. When these both numbers are same, you stop. And over here it will be A power 0 and B power n. So this is what happens, and this is how we get the formula. Now let's look into a problem using this formula. Over here we have 2c minus 6d the whole power 4. Now let me just write the formula. See over here it's there. Let's use the same one. Now I'll write it for this. So it is how much? Power 4, right? So n will be 4. 4c0. What is a? A value is 2c the whole power n. That is again 4. And what is b? B is minus 6d. See, some students forget this negative sign. Then it's wrong. Please don't forget that. Plus, now you have 4c1. What is a? Again, it's 2c the whole power 3. I'm directly doing it. 4 minus 1 is 3. And what about this? Minus 6d the whole power 1. From 0 it increases to 1. 4c2 is basically 2c the whole square because it reduces. 3 minus 1 is 2. And minus 6d the whole power 2 plus 4c3 2c the whole power 1. And over here you have minus 6d the whole power 3. And lastly we have plus 4c4 2c the whole power 0 minus 6d the whole power 4. This is the formula for this particular thing. See, this is the general formula. Now I've used the power 4 and these a and b values. Now we have to simplify this. 4c4 is basically 1, or you just use the calculator. I will show you in calculator how to do it. Now you need to press 4. How do you get the c? That is by shift and the division symbol gives you c. And what is it? 0, right? The answer is 1. If you use the formula also, you'll get the same answer. So 1. And now here, the other terms, it's 2 to the power 4. So 1 times, here you can do 2 to the power 4, c to the power 4. And what about this? Anything power 0 is 1 itself, so I'll ignore that part. Plus, what is 4c1? It is 4. So 4c, just change this to 1. It'll be 4. And you can just change this to 2. And it'll be 6. And now 4c3, it's going to be 4 again. And so on. You can easily find it out. Write the coefficients first. And then you can solve it up. Now I know it is 4, 2 to the power 3 and c to the power 3. And then what do we have is minus 6 and d. Then we have 4c2, that is 6. And here we have 2 square, c square, minus 6 the whole square, d square. Again we have 4, 2c, and this is minus 6 the whole cube and d to the power 3. And lastly this one will be 1, and this is also 1. You're remaining with only, I'll just write it over here, plus minus 6 the whole power 4. Please don't forget the bracket. Now this are multiplied, minus 6 multiplied by 4, so it's basically a multiplied by b the whole power anything, okay, n. So it'll be a n b n. If it is plus, we have to use this identity for binomials. But since it's multiplying, you have to do this. But now a is what? Minus 6. So be careful, minus 6 bracket, power 4 and d power 4. Now we need to use a calculator and solve these up. So this one, first one, it'll be just 2 to the power 4. So you can do it in mind, but it'll take a long time. So it'll be 4, 8, 16, c power 4 plus, now this one over here, 2, 4, 8, 8 times 4 is 32, 32 times 6. So that's going to take time. It'll be 192, I believe, but it'll be minus now. So just make this minus and solve it, but I'm not going to take risk by calculating mine. Do use your calculator because these are many terms, right? And see, the sign also matters. Now I'll show in calculator how you can put everything and solve. Now here what you do is put 4 multiply bracket 2 to the power 3. Okay, or you can do like this, bracket then power 3 and then multiply. Why I'm putting bracket even if it's positive? It's better to do it because then you won't miss the bracket for minus sign as well. So that's the reason. And then we have minus 6 over here, bracket it. And it should be minus. It's not plus, it's minus over here. And then what about the terms? It is c cubed d. And what about the next thing? It's the same thing, just change these values. It'll be 6. And what about this 2? Now it is power 2 only. And then we have minus 6 power 2. So it's squared. And you get the answer, it's 864. And so on. You can solve others by yourself and you can see the answers. Now look at the terms over here. It is c power 2, d power 2. Yes. Last but one is only c, d power 3. Yes, that's correct. And lastly, d power 4. That's how we get the answer. So this is the final answer from binomial theorem. Now we have some real world problem. A school band went to 4 competitions during the year and received a superior rating 2 times. If the band is as likely to receive a superior rating as to not receive a superior rating, find the probability of this outcome by expanding superior rating plus no superior rating whole power 4 around to the nearest person. So now binomial theorems are very helpful to find the probability of things happening as well. Now here we need to expand. This is just now what we did, right? You got this answer. Now here they have told superior rating. See, the school band got superior rating, that is S, and not superior, not receiving it is N. 2 times is what they want for both. So it must be 2 times superior rating, not superior rating 2 times. If they asked you, say 3 times superior rating and not likely, like 1 time not having, then this would be the term. But now since they have told received a rating, superior rating 2 times, if the band is as likely to receive the superior rating as to not receiving, that means both are same. If this is 2, this must be 2. True 2 itself, sorry. Now this is 6 s squared n squared. Now that is just the chances of the total possibilities. 6 times they will get 2 and 2. But what is the other probability? See, 4 times this band will get 1 superior rating and 3 times no superior rating. Whereas 1 time no superior rating at all and 1 time all 4 superior rating is the probability. And over here you can see 4 times they'll get 3 superior rating and no superior rating at all. So 6 is 2 and 2. So this is a favorable outcome. Probability is what? Favorable outcome divided by total outcome, right? Favorable or desired, okay? And total. So here 6 is favorable. What is the total? Add them all up. 1 plus 4, 5 plus 6, 11 plus 4, 15 plus 1, 16. So this is the probability. Just put it in the calculator. You should get the answer. So let's look. It's 38%. It'll be 0.38. Just multiply this by 100. You will get percentage. So 38% chance this particular school band performing will have 2 superior rating and no rating in 2 other times. The next problem is similar, just like what we did a while ago. Now here they have asked 8 free throws short. Okay, 8 free throws are short, making 6 free throws and missing 2 free throws. So in the final answer, after you expand it, where is 6m? M is making free throws. Where is 6? Over here and 2 no. So it's 28 probability. So it is what? 28 divided by the total number. Add all 1, 8, 28, 56, 70. 56, 28, 8 and 1, it will be 256. So 28 divided by 256 is 11%. So there's 11% chance that Oliver, who is playing, will make 6 free throws and will miss 2 of them. So it's 11%. And similarly, now this is just expansion we did just a while ago. Same concept. Here you do not need to use the formula. You can directly use the calculator. See, write the basic formula. What I would suggest is you just write like this: a plus b the whole power n equals nc0 a power n b0 plus nc1 a power n minus 1 b power 1 plus dot 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 plus ncn a power 0 b power n. Write this formula. This is the standard one. Now looking at this, you can do any of the formula. What is this? It's phi c0. What is a? It's 3x power phi. What is b? 4y power 0 plus, and then you can continue it. And then use the calculator to just directly get these coefficients, and then you can simplify the numbers as well. So please do solve them by yourselves. These are similar problems, the same. Please go through each of them. Like, if you understood this thoroughly, it's fine. Try to find little unique ones, especially the minus sign, because many times students tend to miss the minus, And if it's fraction, you can write it as 0.5 or you can keep it as half, no problem. Especially problems like this, whenever there's minus, students tend to forget this minus sign. So be careful over here. I just realized even the solution set has missed the minus signs. And I think so this is wrong over here, because see, x power 4, next one will be x power 3. This is wrong, x power 2, 1. See, there's a way, if you've forgotten the sign, this will be, first one will be positive, next one is minus. Let's see, this is a wrong term, it's not there altogether. Plus, minus, plus. So this is, let me just solve this one, I'll solve it. Let's make it clear. So what you do is, binomial theorem. Let's write the formula. If you're doing it for the exam, please remember it's nc0 a power n b power 0 plus nc1 a power n minus 1 b power 1 plus dot 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 plus ncn a power 0 b power n. Please write this formula. If you are going wrong anywhere as well, for the formula, for everything in detail, you get more marks, So it's like that. So this is for a power n. Now here what we have is power 4. So it's 4c0 and a is x power 4. What about b? It's minus 1/3. 0.33 negative power 0 plus. Next one is n is again 4c1 a to the, okay, not a, it's x to the power 3. Why? Because it's 4 minus 1, 3, and then we have negative 1/3 to the power 1 plus then 4c2 x power 2 negative 1/3 the whole square, and then we have 4c3 x power 1 minus 1/3 the whole cube, and lastly we have 4c4 x power 0 and minus 1/3 to the power 4. Now we simplified, 4c0 is 1, x power 4, this becomes again 1. So it's just x power 4 over here. What about the next term? 4c1 is 4, x cubed, and this is minus 1/3 only. Plus, what about 4c2? 4c2 will be 6, right? Yeah, it's 6. X square, and over here it will be minus 1. Okay, now over here, square it up. Minus minus becomes plus 1 square, 9. That's the answer. And we have 4c3, again it will be 4, and we have x minus remains over here, 1 by 9 cube is 27. And lastly we have 4c4, that is 1. And what happens over here is minus, since it's even power, the minus dissolves. Whenever it's even power, minus and minus, it's become positive. Again, minus and minus even always will be positive, but if it's odd, it's over here positive, positive, and then with minus it will be negative. So it's 1 times x power 0 is 1 times 1 by 3 power 4 is 81. So that's the answers. Now we are to simplify it further. X power 4, Now here it will be negative, not positive. It's negative 4 by 3 x power 3. Then what happens here? 3 table goes 2 times, 3 times. Or put in the calculator, 6 by 9 is 2/3. And this is positive 2/3 x power 2. Now this minus sign remains. And over here it is 4 by, this is x. Okay. 4 by 27x. And lastly we have plus 1 by 81. So this must be the answer. Let's look into the final answer. See, this is minus. I told you this term is wrong. This is plus. This is minus again, you can see. And lastly, this is plus. So please note for the question 14, this is the correct answer. Please don't follow all the solution sets blindly. Just make sure you look at it, analyze it, and then if there are errors, please make sure you solve it properly. And the others, please do it by yourselves now. So these are the solution worked out, and over here, and that is the end of this question 19. I hope you have found it helpful, you have understood it thoroughly. Practice few problems, be thorough with the formulas. No matter what, write the formulas at the beginning. For Pascal's triangle, draw the triangle and then solve the problem. The last question in the writing part, question number 20, is to simplify expressions involving radicals and rational exponents. These are very simple type of questions. Over here you have to just solve the square roots, or it might be cube root or different exponents. Now you must remember, whenever we have plus or minus, why do we put this is because inside the square root, right? Now imagine it's 4. So here this is either 2 times 2, that is 4, or it will be minus 2 times minus 2, that is also 4. So we do not know exactly how the square root is made up of, either 2 and 2 or minus 2 and minus 2. So what we do is we write plus or minus 2. So plus or minus because both can be possible. Now here, pretty simple, because you just put this in the calculator, the number part, you get the answer. But what about these powers? There are a few things you must remember. First of all, square root, say x square root x is x to the power half. Now if this is cube root, it is divided by 3. So whatever is the radical over here, say 5, this can be written as x power 1 divided by 5. Now what if it is something like this, x power 3. So write this x power 3 as it is like this and divide it by what? 5. That's how we do it. Now here, since we have 16 already, see the left part is very simple. It will be 225. In calculator you get the answer. But about this, a power 16 divided by what? It's 2. b 36 divided by 2. So the answer is square root of 225 is 15, I believe. And over here it's a power 8 and b power 18. So this is your answer. As simple as that. Over here, square root of 121 is 11. Oh, now don't forget the plus or minus. Plus or minus 11. And 4 divided by 2 is 2. Y divided by 16 divided by 2 is 8. We got this over here. Same way you can solve it. Now since it's writing, don't directly jump to the answer. See over here what they have done is, basically, the answer you can directly write. Say looking at it, plus or minus 7x power 2. Right? What you need to do is the same thing, write it up over here, 7x power 2, the whole square. So basically the square root and square cancels and then you get this. So the easier way is, let's do this one. Square root of 400 is 20, x 32 by 2 is 16, and y 20. That is the final answer, and it's minus, so write minus. They have clearly mentioned only the negative answer is what's required. Now here, let's write minus itself, but the same answer within the bracket and outside the bracket you should put square. So these are the steps. Now one more thing, if at all you have odd powers, if we're not having any odd powers, okay, over here there is odd power. See, this is the answer over here, the steps. Now always remember, inside the square root you cannot have negative numbers, right? Now what is this? It's imaginary. Why? Because the square root means you have a number. See, now it's 4, right? If it's 4, This number is made up of two numbers, 2 and 2, or minus 2 and minus 2, such that they are multiplied to each other and you get the answer. So if it is negative, any negative value, when you multiply with the negative value with itself, it will be positive, right? So there is no number which you can multiply 1 or minus 1 or minus 1. You won't get a negative answer. So that's why this is a very unique thing. If you have square root negative 1, that means it's imaginary. It cannot be a real number. Now, why did I say that? Because over here it's single power, then this can be negative, right? Whereas if it's always a even power, see, all these even powers means even if you have minus, say x is minus, when you square it up, it'll be minus 2 times minus 2, it'll be positive 4. So every time when it's even, minus, 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 it becomes positive only. But this one, odd, if you have minus, it's minus. So this would be a problem. So that's why you write this magnitude symbol, just stating that only the positive value was considered. So only when there is odd numbers, just write these two symbol, magnitude symbol, modulus. Now here we have root radical of 4. See, again it's simple. So the answer directly would be, splitting out, divided by 4, and this is radical 4. But now if you're doing in steps, this is a better step. What I would do is 416, and then I would split it out to x minus 3 the whole power 12. And now then this can be obtained from the calculator directly, but if you know it is 2, I believe 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So the answer is 2 here. And this one, what you have to do is x minus 3 the whole power 12 divided by 4, right? So it is 2 into x minus 3 whole power 3. 12 divided by 4 is 3. Okay, that's the answer. But here, since it's odd, it's very, very important. Say the power is odd. Now, if you have minus 2 the whole power 3, what happens is minus 2 times minus 2 times minus 2, right? This becomes positive 4, but this another odd sign is there, it becomes minus 8. So minus remains. But if it was positive, it will be all positive. But if it was even number, even power, and if it was minus, then again you multiply it with minus, so it becomes positive ultimately. So always remember, when the powers are even numbers are 2, 4, 6, 8, and so on, it's always positive. Whereas odd numbers like 1, 3, 5, and so on, it will always remain negative. So that's how we get this. So over here, you just write modulus. So what you can do is x minus 3 modulus the whole power 3. So this is basically the answer. Just write modulus, that's it. You can write modulus outside, okay, in the sense over here that whatever the value is there, whatever this answer, we just take the positive value of it. So that's how we can write it. Now here, because this only term could be negative, right? You must have the absolute value. That means it'll be a non-negative answer. Same way over here, you can directly jump to the answer. It's 16 divided by 8 is 2. And y divided by 8 divided by 8 is 1. But since this is odd power, you put the modulus symbol, that's it. But for writing, just do these steps. These are very simple to write, very, very easy problems. Same thing goes over here as well. Nothing much over here. 18 divided by 6 is 3, but since it's odd, you write these two lines. Over here, radical 4 of 81 is 3, because 3 to the power 4 is 81. You can use the calculator to do it. And then x minus 1, it's odd, so you write these two lines. Now, if you're thinking how to use these symbols in the calculator, you can see over here, this is the square root symbol. But what if you want to put a radical over there? It is by pressing shift, and you can see this x power, right? But if you press shift and this, it comes as radical. So you can put anything, and then this is the radical symbol, radicand, and what do you want over here? You can put any number to, this is the answer. So that's how we solve it. You can try any problem. And this is again same, 12 divided by 4, how much is it? 3. But it's odd, so write these two lines. Now again, 12 divided by 3, it's 4. You do not need to write the modulus symbol over here. The absolute value is not necessary. Why? Because it's an even power. Whenever there is odd power, put these two straight lines. I wish you all the best, guys. Please do practice more problems and write and study. Don't just watch it. When you're watching the video, please try practice writing. Before I finish off, I just want to thank each and every one of you who have subscribed to my channel, who have liked my videos, who watch my videos. It really means a lot. I really am amazed by the support and love I receive from all the students. Thank you so much. I will try my best to do all the explanation videos as soon as possible. Please do stay tuned.